Good afternoon, Algebra 2. Today we are going to be starting our new unit, Chapter 8, and we're going to be talking about first composition of functions. So essentially what a composition is when you have two different functions and you need to perform them both on a certain input, okay? You would perform, of course, one and then the other, and then, of course, order does matter usually here with these. So let's take a look at our first example. You do not need to write this down. I just kind of want to talk about the significance of compositions here. All right, so it says, suppose a car dealer offers a $1,000 rebate and a 15% discount off of the price of a new car. If the sticker price of the car is $13,000, that means what we're selling it for, how much will you pay? And some people, they go car shopping, and they don't really think about, all right, well, if I'm getting $1,000 off and then a 15% discount as well, it doesn't really matter what order that they do it in. And, car companies could take advantage of you this way because you don't know any different. One is better than the other, and yes, it does make a difference. So let's take a look at which one we'd want them to do first here. It says, if you are given the rebate first, so the $1,000 off, and then the discount, so then that would be the 15%, the selling price is, so this is the $1,000 here, this is the 15%. So we're going to take $1,000 off the price of a car first. That's why this is in parentheses. So we'd have $12,000, what would be left. And then we'd take that $12,000 here and multiply it by 0.85. Now you might be wondering where this number came from. This number is essentially what we're paying for the car. Yes, they're giving us 15% off. Well, they're taking that off of 100% of the whole price of the car. So 100% take off the 15, which means to subtract, would get our 85%, which is represented by this 0.85 here. Okay, so the 0.85 says, okay, this is the money that's coming out of my pocket after they take off the 15%. So we take the $12,000. We've already taken off our 1,000 here. Take the 12,000, multiply it by 0.85, and you should be following along in your calculator here just to see if I'm right. I might have making a mistake or two here. When you do that, you should get $10,000 or $10,200 as our price, and that's what we would pay here for our car. Alrighty. However, if they tell you you're going to be given the discount first, so the discount was the 15% off, and then the rebate, and the rebate was the $1,000 off the selling price. So now we take the full $13,000 and multiply it by the 0.85, which is, remember, what we're paying after we take the discount off. So if we take that full $13,000, take it 85% of it, which is what we're going to pay, then take off $1,000, that's going to give us $10,050, which, that's a difference of $150. That's probably 3 months worth of gas right there. So this is $150 cheaper. So I would say, well, hey, take the discount off first and then give me the rebate, okay? The reason that this works is simply the idea behind percentages. If you have 15% off of something, if you're paying, let's imagine $1 million for something, well, that's going to be a much greater discount than if you were going to be paying $100 for something. So the percentage is really what's throwing everything off here. So you want it to be the greatest amount possible being multiplied by the percentage. Okay, that's going to give you the highest discount. So therefore, applying the discount before the rebate results in a lower selling price. Okay, and what we just did there was a composition. We did it actually both ways, which doesn't typically happen, but you can do them both ways to compare. Here we did the rebate first, then the discount, and then here we did the discount first, and then the rebate. So those were our two functions, if you want to think of them that way. Let's take a look at what you're going to be seeing in. Alright, example 1. Suppose R of x equals x minus 1,000 and D of x equals 0.85 times x. If you notice, these are our rebates and our discount from the first problem here. So we're actually, this is kind of how you would see the setup of your compositions that you're going to be doing tomorrow. It says A, find a formula for D of R of x. That's all that this really stands for. Remember, we used to just have f of x or g of x or r of x. When you put it inside of another function, it becomes D of R of x. So you just kind of say things twice there. It is kind of how it works out. Let me get my pen here. And actually, I'm going to leave this red. I'm going to call R of x, we're going to put that in red, and then D of x, just so we can tell them apart here, is going to be, let's do a blue color. We'll go blue. and that's going to be blue. So when I put my r of x into my d of x, you can actually tell which piece is from which function here, okay? So we're going to be putting in r of x, which is x minus 1,000, into this function for wherever x is. So x is right here, and remember this is 0.85 times x, so I'm going to actually put this x minus 1,000 in parentheses just to keep it all together. So it starts out d of, I'm just going to get a little tricky here. Let's see how good I am with this now. So d of, here's r of x, that's why I switched colors to red. And then we're back to blue for d of x. Okay, so that's all d of x. And then in it, we put r of x right in here for x. And then on this side, we have d of x still, so 0.85. Okay, and then we flip, and we're actually going to put in r of x here. So I'm going to grab my red. And r of x, remember, is x minus 1,000. So I'm going to put this in parentheses. And I have x minus 1,000 here. Okay. So the red is the r, or the rebate pieces, and then the d is the discount piece. All right. So all we did was we plugged x minus 1,000 in for x, which is what we're supposed to do here. That's what this wants. So then what we have to do is we actually have to simplify it if you can. Don't leave these like this. Simplify it. So let me get just black now since we're combining them. So what I can do here is I can distribute this 0.85 into these parentheses here. So it becomes d of r of x. We leave this as such. And then 0.85 times x is just 0.85 x. And then minus 0.85 times 1,000, well, that would be 800. Well, let's see, 1, 2, 3 zeros, 1, 2, 3. That would be 850. If you don't believe me, let's grab our calculators here. Remember, anything I do in the calculator, you should follow along with. So 1,000 times 0.85. Boom, 850. Okay, so we're good. Just making sure you guys trust me here. So now, can we actually subtract 850 from this 0.85x? No, because these are not like terms. You have an x here. So that's as simple as we can take it. There's nothing else we can do here. So this is our formula for d of r of x. That is taking both functions, and we've done the rebate first, technically, because this is where we put into the other function, and then we take our discount. Okay, so that's what this represents here. We take our rebate on x first, and then it gets hit with the discount. So you kind of work your way out is what you do. So then it says check your answer to part A by letting x equals 13,000. So then we put 13,000 in for x. So we have d of r of 13,000 now equals 0.85 times 13,000, whoops, 13,000 minus 850. So again, I'm just using this formula here, and I just plugged in 13,000 wherever I saw an x, and now I'm going to evaluate it. So of course, order of operations says do this part first, so 85% of 13,000. Let's get this out. So 0.85 times 13,000. It's going to give me 1150. Okay, so let's write that down. So $11,050, and then don't forget we still have to subtract off 850 from that, so minus 850. Oops. Alrighty, so let's do that. So minus, come on calculator, there we go, minus 850, and we get 10,200, which was actually the higher price if you remember. So that was what we got the first time when we did the rebate, or excuse me, the discount first and then the rebate. It was the higher of the two prices, and we preferred the other one because I would rather pay less money than more. Alrighty. Okie dokie, so here is your definition. We're talking about compositions here, or otherwise known as composite. This is a composite G of f. This is a new symbol to us. It's just a tiny little circle, and this actually symbolizes the composite. So g of f of two functions f and g is the function that maps x onto g of f of x. meaning you take f of x, you put it inside of g here, and that is your composite. That's exactly the way it's written here. You take f first and then put it into g. So it's kind of, if you want to think about it working inside out or backwards, is kind of how we do it. And then it says, and whose domain is the set of all values in the domain of f for which f of x is in the domain of g. So remember, we spent a lot of time talking about domain and range here too, but domain more importantly because it's what you're allowed to put into our functions, which we've learned throughout a couple of our studies here. There's certain things you cannot put into every function. So it's something we just need to decide how or what we're allowed to put in there. Okay, so we'll worry about that a little bit later. Just know these two important things here. Hang on, let me get my pen so I can underline. Actually, let's highlight. Haven't done that yet. Okay, so when we have g of f of x, this is the exact same thing as writing it this way. Okay, so you're probably going to see both. You need to know that they are one and the same, and that means to take f of x and put it into the function g of x. Either way it's written, take f of x here and put it into g of x. Okay. So ways of writing and reading a composite function, we could have our mapping notation, which you should remember from a long time ago. We won't use this one as much. I'd rather focus on our function notation here because this is the one we usually use, but know that they are one and the same here. So our function notation, we could have g composed with f of x. You could read it like that, g composed with, or g, I just like to read it g of f of x. It just helps me keep it in order. It's the same exact thing as g of f of x. This is written the same way here. So this, remember, this one was with parentheses and equal signs, our function notation. But we could have mapping notation, so let's go look at that. Well, we won't leave that out. Notice we still have our composite sign here, this little circle. G composed with f of x, this says the same thing, maps onto g of f of x. Okay, so these are the same over here if you notice. So basically all of these statements are equivalent. Okay, so g composed with f of x equals g of f of x. Okay, so it's a lot to deal with, and it's interesting because we haven't really dealt with any of these before. So let's look at a couple of them. I'm going to wait till the next video. And sorry, I'm changing my pointer out here. I hope you're still copying stuff or something like that. Okay, there we go. We will be doing a few more examples so you can kind of see what is expected of you. But we'll wait till the next video, so see you in a bit.